But in any case, what you do need to know is once you create that patch.hawk file in Notepad, and Notepad will not do this to you as it's doing to me, is that you need to know basically what do I need to even do to see what's going on in the model. Well, what you need is the basic views. And the basic views are run control, which showed up on this side. And run control basically controls simulation time parameters. In it is basically the initial potential. So basically where the cell or compartment starts, in it and run will basically start the simulation, stop will stop it, continue will say let it run, or continue till will say how long you let it go, continue for, let it go an extra number of time steps, and on and on and on. But basically for the most part, what you need to know is initialize and run. Now, the other important thing is the voltage axis. This is actually going to show you the potential as a function of time. And then finally, in order to actually get the model to respond to something, you need to have some kind of what they call a point process, which would be like a stimulation. And essentially what it means is, you know, what are you going to apply to the model to have it respond? In this case, what we're going to be talking about is an I clamp, which would be a current clamp. And as you can see, it recognizes the model that's defined in the .hoc file, which is called SOMA. And it's a SOMA with a diameter of 100 microns and a length of, I believe it's 10 microns. So it creates an 100 micron or cubed sphere, lipid bilayer membrane bubble. And essentially what you do now is you modulate the parameters of the current clamp. And once you do that, like for example, you can do pretty much anything that you can think of doing in here. You can do division, addition, and all the general math operations. And it's basically going to go ahead and apply them to the model. And then once that's done, you go back to your run control, and there's where you do your initialize and run. And what it'll do is it'll apply the parameters from the point process, which is a stimulation, to the actual geometry that you defined in the .hoc file. So if I change it and I click here, it recognizes it, I run it, and as you can see, the potential goes from the negative 65 to approximately lower than 40, like about 32 or something like that. And for what we're talking about today, this really helps you know like a little bit more about what the actual software is doing. But then this is just a bubble, so this has nothing to do with our class for the moment. In order to make it more relevant, we're actually going to go ahead and add something from the distributed mechanisms managers inserter, and then what that's going to let you do, and this is in the PowerPoint. So it pops up this little menu here, and it mentions SOMA, which is the geometry that we defined. So if you pick HH, what that does is it adds Hodgkin-Huxley channels to the model. Now, once that's selected, you go back to your run control and you do initialize and run, it changes everything. It actually starts looking more like a Hodgkin-Huxley potential. So that was basically from just going into tools, distributed mechanisms, managers, inserter. So at this point,
Can you change the duration of that? I want them to see the several action potential. Can you go to the stimulus window and put and change to duration, let's say 50 milliseconds. And amplitude probably is okay. More amplitude, one point. I think it's not working. You are integrating only till 5? Can you go to the, can you go to put time T in this window, say? In this window here.
this window,
Yes, put, instead of 5, put 100. No, there, in T. And put stop at 100. Okay, so I don't know why this cell is only responder as one single action potential. We have to see the channel we have picked up. But basically this is what we want to see, is different action potential generated. It have to be several action potential. I don't know what's wrong here.
that is strange, because then it dips down.
Change the amplitude, see? No, I don't think amplitude. It's already saturated. It's already saturated. I think it's reduce the amplitude a little bit. Reduce more. 0.1. Yeah, well, put 0.05. Yeah. So yeah, you get the train of action potential. Because what you have, the current that you have to inject is depending on the size of the neuron. You have a neuron 100 micrometer in diameter, you inject 400 microampere, you're okay. But if you're injecting too much current, you're saturated. So we fight it first, and the capacity will saturate. So this is a train of action potential that we are expecting that you explain. No, you saw that before we saturated.